So there are different forms of the same element. Okay, but the only thing is their neutron is different. Okay, everything else of isotope is same. Okay, the number of protons is same, number of electrons is same, even the chemical reaction they undergo is same. The only difference that we have here is the different number of neutrons. Okay, so I gave you example. Okay, we have an example of carbon element. Okay, so we have carbon element, and if I just give you 100 gram of carbon, okay, if I just hand over 100 gram of carbon for you, okay, so that particular 100 gram of carbon will be having two forms of isotopes of element in it. One is this carbon 12, okay, and one is this carbon 13, okay. One is carbon 13. We have one more isotope, carbon 14 as well, but here we will be just talking about the carbon 12 and carbon 13. Okay, so it can be that we have more than two isotopes of the same element. Okay, it's not necessary we have only two isotopes. We can have many isotopes of a particular element. Okay, so just to give you an example, we will be taking carbon 12 and carbon 13 isotopes. Okay, so what is carbon 12? It will be having the atomic number, sorry, it will be having the atomic mass 12, right? This is what? This is the atomic mass. Okay, this is the atomic mass. So it is having atomic mass 12. Okay, now what is atomic mass? It is the number of protons plus the number of neutrons, right? This is the atomic mass, okay, or the mass number. Okay, so we already know that this carbon 12 is having how many protons? It will be having 6 protons. Okay, what is the 6? This is the atomic number, and that tells us the number of protons. Okay, so we are having 6 protons here. Okay, and we have to find the number of neutrons, right? So can we find the number of neutrons with this?
Yes.
What will be the number of neutrons over here? It is 6. Okay,
It is.
this is 6. So we
And
have,
then the number of electrons is 6 as well.
yeah. So this is the number of proton is 6, the number of neutron is 6, the number of electron is also 6. Okay. On the other hand, if we just see this carbon 13, right? This is a carbon 13 isotope of carbon element. Okay. So here the mass number is 13. Okay. So what will happen now? The proton will remain same because the atomic number is still same here. It is 6 only. Since the atomic number and the number of proton is same, we will have the electron also same. It will be 6. But the neutron increases by 1. Okay. So here we have 7 neutrons. So this is the only difference between carbon 12 and carbon 13 isotopes. Okay. So chemically also they will react the same way. The number of protons and the number of electrons remains the same. The only point of difference that these isotopes have is that they have two, they have difference in the number of neutrons, right? Are we clear about this, Naveen?
Yeah.
Sorry, Nikhil. Yeah.
Naveen is here though.
Okay,
He's
he
right
is
there.
here. Okay, okay. Hi, Naveen. Welcome back from school.
Hi.
Hi. Okay, we'll see you in the next hour. Okay. Okay. So, this is what we know about isotopes. Okay. Now, I said that if I just give you 100 grams of carbon, okay, I said if I just give you 100 gram of carbon, you will be having two isotopes of carbon in it. Okay. So, how do you know that which carbon atom is present in the more amount and which element is present in the lesser amount? Okay. So, we are having C12 and C13, right? We are having C12 and C13 over here. Okay. So how do we know that C12 is more or if C13 is more or if both are in the equal amounts? Okay. That is determined with the percentage abundance. Okay. What is meant by abundance?
Um,
What is meant by abundance?
abundance is like a lot of.
No, abundance. Yeah, abundance of water. So what is meant by, what do you mean by it? Abundance means the availability. Okay. How much availability do we have? Okay. So what is the abundance of water in the earth? Tell me. It's around 96 to 97%, right? So this much water is available. That is what we are trying to say. So percentage abundance here means that this much amount of percentage of C12 is present and this much amount of percentage of C13 is present in a given sample of carbon. Okay, so this 100 gram that we have here, this 100 gram is the sample. Okay, we are giving you a sample of carbon. Okay, so this is the 100 gram of sample of carbon that you are having. Okay, so in that 100 gram, how much availability of carbon 12 is there and how much availability of carbon 13 is there, that is determined by this percentage abundance. Okay, so maybe in this 100 gram, maybe 60 gram is carbon 12. Okay, maybe 60 gram is carbon 12 and maybe 40 gram is carbon 13. Okay, so what will be the percentage abundance of carbon 12? What will be the percentage abundance of carbon 12 in this sample? It will be 60%. And what will be the percentage abundance here? It will be 40%. Am I clear?
Yeah.
Yeah, okay. So based on this percentage abundance and the atomic mass is given, we can calculate the relative atomic mass or the average atomic mass. Okay, so if we just want, okay, suppose if we just want this one, just take this example only, wait, just take this example only. Okay, so if I just give you this carbon 12, okay, and this carbon 13, I just gave you a sample of 100 grams, right? We just give you a sample of 100 grams, right? And we need to calculate the mass, average mass of this carbon 12 and carbon 13 in this 100 gram of sample. We have to calculate that. Okay, so how we will do that? Why we have to calculate the average masses? Do you think the atomic masses of these carbon 12 and carbon 13 is same? Do you think that this is what is happening here? It is 12 here, it is 13 here, right? So the atomic masses are different or not?
Yes.
Yeah. So we need to calculate the average mass of carbon that is present in this 100 gram of carbon. Okay, the average mass of the carbon, average atomic mass of the carbon that is present in this sample. Are you getting my point?
Yes.
Okay. So how we will do that? We have a formula for it. Okay. So we will just move on to a new. Okay, so just different isotopes have different masses. So when we can calculate the average mass of all the isotopes that make up an element, we call that mass as the relative atomic mass or the average atomic mass. Okay, it's better if you can have a paper and a pencil or a notebook or a pencil over here. We'll be doing some questions today, some numerical
Oh,
questions.
okay.
You already have it?
Um,
Good.
I have a paper on second. Let me go get a pencil.
Okay, just go and get a pencil now. Hello, Nikhil, are you there?
Oh yeah, I kept saying like I got a pencil like on my screen, my video, and I on my video and I'm unmuted.
Uh,
I just I and then closed
okay,
my video and then I on it again.
okay,
I kept
okay.
saying I had a pencil, have a pencil, I have a pencil. I kept saying I was wondering why you couldn't hear me.
Okay, in that case, now you just send me a chat. Okay, then I'll let you know. I was just waiting. I thought it's like, why is it taking so long to get a pencil? Okay, no
Okay.
issues. No issues. Okay, so we have this question, okay, and we have to calculate the relative atomic mass of copper to one decimal place. Okay, so we have two isotopes of copper. This is copper 63 and this is copper 65. Okay, so the atomic mass of copper 65 is 65 and copper 63 is 63. Okay, and this is the relative abundance. It is 69.2% and it is 30.8%. Okay, so how we will calculate the relative atomic mass of this? Okay, so this is the formula that we will use. Okay, so what is this? This is the sum of isotope abundance into isotope mass of each element, then by the sum of abundance of all the isotopes. Okay, so we will just substitute the numbers for this. So what is the isotope abundance for copper 63? It is 69.2%. Okay, into what is the atomic mass, it or the isotope mass, it is 63, right? So we are just putting this and we will add this to 30.8, that is the relative atomic mass of copper 65, into 65, that is the isotopic mass of copper 65. Okay, now what we have to do, we will just divide it by the sum of abundance of all isotopes, that is 69.2 plus 30.8. So can you just solve it for me? What is the answer here? Just solve it and let me know.
Okay.
Yeah.
So 62 times 62 times 63, my bad.
Just tell me the numerator part first. Then we can just keep on simplifying it.
Okay. 100.
No, the numerator part. This is the numerator part and this is the denominator part.
Okay.
So the denominator part is 100. What about the numerator part? Tell me. Just
Okay. Is 6,361.6.
okay, just a minute. You're using a calculator, so I guess it's right.
Yeah.
Yeah. So what is the answer you told?
6,361.6.
361.6. Okay, so this is the answer we got. And if we will just and what will be the answer after this? Do we know the division of decimal divisions? Do we know the decimal division? Decimal multiplication and decimal divisions. Do we know about that, right? We can do, no?
Yeah, so the
Okay.
denominator?
Yeah, so the denominator is 100, right? And the answer we are getting is 6361.6 by 100. So what after this?
63.616.
Yeah, okay, so 63.616. And since we are asked to round it off to one decimal place, so what we will do, we will just write it as 63.6, right? We are just writing it that like 63.6. So let us see if we have done it correctly or not. The answer is 63.6, right? So we will
Yeah.
just see if it's correct or not, and then we can do more questions like this. Okay. So yeah, so this is 63.61, and we are asked to round it off to the one decimal place, so it is 63, right? 63.6. Okay, so what is this? This is the relative atomic mass of these two isotopes in the given sample amount. Okay, so 63.6. Okay, so and how do we denote the relative atomic mass? We will denote it by this symbol. Okay, this is A, and then we have to write an R. Okay, so this is the relative atomic mass symbol. Okay, so can we just do some more questions like this? You can use calculator. Okay, it will help us save the time, but we need to practice these long calculations also. Okay, because it will be like difficult when you do it in the exams. I don't think you are supposed to take calculator in the exams, right?
Yeah.
Yeah, I gave these questions to your brother and he just suddenly went bored of this subject. He said he doesn't want to continue with this particular chapter. So let us try doing this. Are you able to see my screen?
Yeah.
Yeah, so just try to solve this. So an element has the following natural abundances and isotope masses. Okay, so 90.92% with abundance, 90.92% abundance with 19.99 atomic mass unit. Okay, so this is the atomic mass unit. Okay, we don't write grams or kilograms for atom. Okay, what is the unit we use? We use AMU. Okay, and what is AMU? It is the atomic mass unit. Okay, so 19.99 AMU, 0.26% abundance with 20.99 AMU, and 8.282% with 21.99 AMU. Calculate the atomic average of this element. Okay, average atomic mass of this element. Okay, so we have three isotopes over here. Okay, so what we have to do, we will have to just take the sum of abundance of all isotopes into the atomic mass of all the isotopes divided by the total abundances of all the isotopes. Can you do this? Did you get the question or not?
Yeah.
Yeah. So can we do this question?
Yeah.
Okay, just try doing it. Just try doing it, and if
Wait,
you
can
want to.
you write? Can you like write the numbers like how it's in like the copper, like how copper is written? Can you write it like that?
You are asking me to like put it in the formula form.
No. I'm just asking you to write it in like you know how like copper is written, right? 63 Cu, uh,
Okay.
29
That
copper.
you are asking.
Yeah.
Okay. Just a minute. I'll write like that. Okay. I'll write it in the whiteboard itself. Just a minute. New share, whiteboard, share. Okay. So okay, we have this element A over here. Okay, with the atomic mass 19.99. Okay, and the relative abundance of 90.92. Okay, this is the relative abundance. Now we have an element B I hope this is what you were asking for.
Yeah, yeah.
Yeah. And we can write here as 20.99 0.26%. Okay. And we have another element over here, that is element C. They both are the isotopes of the same element. Okay. So
Okay.
20.99 and this is 21.99. And what is the relative abundance of this? It is 8.82%, right? Okay, this is 8. Okay, so now you can solve it. Tell me.
Okay.
Okay. If you want, you can use calculator also. Okay. I'll also try to solve it. Okay, I already solved it for Naveen yesterday, I guess. Yeah. You can just tell me the final answer, right? Just
Yeah.
tell me what is the final answer.
Okay. We have to do all 3 of them?
Yeah.
Okay. That's fine.
We have to find the average atomic mass for all the 3 of them. So how will you calculate it?
Okay, so 19.99 times 90.92.
If the meeting gets over, you can just log in again, okay?
Okay. Wait, is that a 6 or a 7?
Where?
For the last one, C.
Where? There is no 6.
On the bottom.
This is 21.99 and this is 8.
Oh, 8, okay. Okay. Then we have Okay, I got it.
Yeah, what is the answer?
It's 20.169.
Very good. Okay, 20.16. What will be the SI unit? What will be the SI unit? 20.16. It is the correct answer. But if you don't write the units, your marks will be deducted. Right. So what is the unit I told you? It is AMU. Okay. Atomic mass unit. Okay. Okay. So I'll just close this whiteboard. Okay. Now we had one more question, I guess. Yeah. Try solving this question as well. We'll just practice some questions, right? So we know if we are getting the point. Read this question and try to understand.
Okay.
Okay, whenever you have problems like this, okay, generally you will be facing these problems in forms of MCQ, okay. Object when you will just be sitting for objective questions, you will be given these types of question, right? And at that particular time, you don't have this much of time to read the entire story of this. We don't have time to read this whole question, okay. It's so much of statements are there, useless informations are there, so we just need to see questions, okay. So what will you see? You will just completely ignore these first two statements. It is not at all relevant to the question we are solving, okay. So how where from where we will be reading? This bromine has two isotopes, right? And what is given? 79, 81, okay. And what are the masses? It is this